Here we have an investigation to practice. In this video, I'm not going to do the whole investigation. I'm just going to do what would essentially get about a grade of a 4, maybe a 5. I want to create a table that I will use to try to look for a pattern. I will describe the pattern with words, and I'm going to try to find a way to describe the pattern using variables and algebra. I will lastly verify the pattern. So we are only going to go through these steps in this video. So let's get started. What are we even looking at here? It says consider two numbers, 5 and 7. Okay, I have two numbers in my mind, these two. Find the mean of those two numbers. So I need to do, that's a step, and then square it. So that's another step. Now square each of the two numbers separately. So that's 2 more steps, and find the mean of their squares. That's one last step. Now choose 3 other pairs of numbers. Okay, so these are, I have to do these 5 steps. And there's not really a lot of space on here. We will be switching to another paper to write this down. So this means I have one starting number, second starting number, and 5 steps. I need to create a table that has 7 columns. So my table is going to be very basic. I just have a horizontal bar. I'm making it really long because I said 7 columns. And I want 1 column for every step or every number they tell me to think of. So there was my starting number, which in our first case was 5. And then there was like the next number. I think these colors. So our starting numbers were 5 and 7. And then we're going to make a new column for every next step they ask for. So they said, find the mean of these two numbers. Great, that's a step. That makes it a column. So the mean of start and next. I don't know why I got rid of the ruler. I don't need it. Then what am I asked to find? Square it. Okay. So I need to, in this next column, square, that's not how we spell square. Square of mean. What's the next thing we have to calculate? Now square each of the two numbers separately first, okay? So I need to find the starting squared and the next number squared. And lastly, find the mean of the squares. So last column will be called mean of squares. So I haven't even started any calculations yet. I was just preparing. Anytime you do an investigation where you're looking for a pattern, you're going to need a table like this. And you really want 1 column for every calculation step. In the end, you'll focus on just 2 columns, but it's a good idea to have all of them to be able to see where the patterns are happening, and most especially to most easily be able to use the abstract algebra version of the pattern in the last step before we verify. So I can fill this out. The mean of 2 numbers. I don't know if you know this from before. If I have 2 numbers and I'm taking the mean, I add them together and I divide by 2. So in this case, it's going to be 6. So the mean of the start and the next is 6. The square of the mean, 6 times 6, so 6 squared is 36. The starting number squared. Okay, so 5 squared is 25. 7 squared is 49. And now it says the mean of the squares. So the mean of these two. The mean, I add them together and I divide by 2. So 25 plus 49 divided by 2 is 37. Let's go back to the instructions. They said, consider these two numbers. Great, I put them in my table. Find the mean, square it. Find the separate means, find the separate squares and square the means. Great, I did all of those things. Now I'm ready to look at the next step, and they say, choose at least 3 other pairs of numbers. So I need to add at least 3 rows to my table. I can do more. If I need more time to recognize a pattern, I'll try more and more rows. And it says pairs of numbers which have a difference of 2. So my pairs of numbers will be like 1 and 3, 2 and 4, 3 and 5. I could even do negative numbers if I really want to be careful about my pattern. I will typically stick with small numbers because it's easier for me to see patterns of small numbers. I recognize how they work better. So for my next pair of numbers, I'm going to go all the way down to 1. I'll choose 1 and 3. The mean of these two, this is the last time I'm going to calculate this out. After this, if you forget, come back to the rewind in the video and look. So the mean of 1 and 3 means I add them together and I divide by 2, and it's going to be 2. The square of the mean. So 2 squared is 4. The starting number squared, 1 squared is 1. The next number squared, 3 squared is 9. And the mean of the squares. So I have to find the mean of these two, which is 5. Try another set of numbers. Maybe I try 4 and 6. So the mean of 4 and 6 is 5. 5 squared is 25. The starting number squared is 16. The next number squared is 36. And the mean of these squares, of these two. So I have to add together 16 plus 36 divided by 2 is 26. I need to do at least one more, because they said at least 3 more after that starting one. And it's pretty important to make sure you have starting numbers that are both even and odd, just to make sure that the pattern isn't accidentally something you notice because of even and odd. I'm going to try a negative number because I'm curious if it works there as well. So maybe I try -2. The next number is going to be 0, because that's 2 up on my number line. The mean is -1. The mean squared is 1. The starting number squared. So -2 squared, that's 4. The next number squared is 0. And the mean of 4 and 0 is 2. So let's go back to the instructions. I've done this. I finished more of my table and I added these 3 pairs. And then it asked, what did I notice? And I'm like, I don't know, what was I even looking for? How does the mean of the squares compare with the square of the mean? How does the mean of the squares compare with the square of the mean? So I'm going horizontally. I want to compare this number with this one, this number with this one, this number with this one, and this number with this one. If I can see the pattern now, then I have found it. If I still can't quite tell, I will add more guesses down here. Maybe I start with 10 and 12. But I can see the pattern. I can see that the square of the mean, this column, is 1 less than the mean of the squares. So we need to describe this pattern with both words and then later with symbols. But with words, what you want to do is take the words from what they gave you. They asked you what pattern you noticed between 2 different things. I'm going to erase all these extra marks. Oh, I lost my 3. So let's copy this down. They asked us, how does the mean of the squares compare to the square of the means. I'm writing this down so that I can copy it to my next page because I want to be using the exact same language in my response that they have used here. So they asked, how does the mean of the squares compare to the square of the means? So here is the mean of the squares is my pink column, and the square of the means is the orange column. I do this so that I can use their own language. I noticed that the mean of the squares, that's my pink column, is one more than. Is one more than the square of the means. It's really important that I can describe this in words, and to get my communication points, I don't want to be calling them numbers. I could occasionally say values, but I really want to be using these titles that I've given the columns that come from the words that I've been given in the actual exam. So here's my first step. I made my table. Here is my second step. I used their words to describe it. This is working out. I wouldn't actually keep it in my paper. Oh, this would be with words, my description. But now we need to use this only using letters. That means in this first column, I want there to be an N. And I fill out the rest of the columns using what is the relationship with that column to N. So I ask, how do I get from 5 to 7? Like, where does a 7 come from? Or how did I get from 1 to 3? It looks like I add 2. So 5 plus 2 is 7. 1 plus 2 is 3, which means when I algebra this, go ahead and make this green. This is N plus 2. In the next column, the mean of the starting number and the next number. We already talked about this. This is literally what happens when I add them together and divide by 2. Because this is algebra, like, you can, of course, simplify this. But in this step, all I'm looking to do is to get an expression. If you want more points in your investigation, it's better to simplify. But for right now, let's just look at what we've got. Okay, and then I'm supposed to do the square of this mean. So I'm supposed to square this whole thing. Again, better if you can simplify, but I want students who have trouble simplifying algebraically to still be able to get through this whole process. Okay, green column. I'm supposed to take the starting number and square it. So N squared. Purple column, I take the next number and square it. Remember, anytime I'm squaring something that has more than one item inside, more than one term, I put the whole thing in brackets. Or even if I'm just multiplying, unless this is literally all by itself, the N plus 2, I will probably put it in brackets. It didn't here, you could, it's not a problem. And lastly, I have the pink column, and it's the mean of the squares. So it's the mean of these two. We get the mean by adding them together and dividing by 2. I've added my variable column to my table to see how I calculated it. And now I just need to fill in the blanks. So here it says the mean of the squares. The mean of the squares is my pink column. So the mean of the squares, whatever I have written in the pink column, is math for is equals 1 more than. 1 more than in math is 1 plus or plus 1. The square of the means. If I look at my table, the orange column, that's my square of the means. So that's N plus 2 over 2 squared. We will eventually need to simplify this completely if we want like full points for this investigation, but that is not our goal today. Our goal today is to really get a very middle score. So I have done a description using algebra of this pattern. And the next thing I need to do is verify. Verify means like plug in a number and see if it works. Any number, it doesn't matter. So let's try 10. So one of the math words you'll use a lot is consider or let. So let's let n equals, literally pick anything. I'm going to pick 10. Now I put in 10 instead of n everywhere in this expression. So I'm going to rewrite it. But everywhere that used to be an n, and now it's a 10. So 10 squared plus 10 plus 2 squared divided by 2 equals 1 plus 10 plus 10 plus 2 over 2 squared. My job now is just to double check that when I fully simplify this side in my calculator, I get the same number as when I fully calculate the right-hand side on the calculator. So let's just focus on the left-hand side. I'm always going to work vertically. So on the left-hand side, that's 10 squared plus 12 squared divided by 2. So that's 100 plus 144 divided by 2. So that's 244 divided by 2, which is 122. Every line needs an equal sign, and we line up the equal signs. Mine are not super straight, but pretty close. And now I simplify the right-hand side. So 1 plus 10 plus 10 plus 2 is 22 over 2 squared. So this is actually a question mark. Like, does it work? Here I have 1 plus 11 squared. 1 plus 121 is 122. It does work. I did get the same thing on the left-hand side and the right-hand side. And that is everything that this video contains. It's just the first 4 steps of any type of investigation. So as a recap, step number 1, we make a table, and the table needs to have a different column for every calculation step. This was a lot. 7 columns is a lot. Sometimes there might be fewer columns. Then I look for a pattern with what they asked. And the pattern is always left to right. I'm trying to get from the number in one column to the number in the second column. I find the pattern, I write it down with words, and I steal the words from the actual question that they asked me. So I'm using the correct math vocabulary. Step number 3 is that we added this bottom row to our table so that we had an algebra version. And then we rewrote the words as an expression using that bottom row. The last step was to verify. Plug in a number instead of n and just double check that the left-hand side of your equals is the same as the right-hand side of your equal sign.